All right, welcome. We are going to give it a few minutes to let some people trickle on in here. But my name's Maria. I have Mark here joining me. Super excited for this webinar. We will be going over sensor technology in food and beverage production. But like I said, we'll give it a few more minutes, let people trickle in. But let us know where you're coming from, where you're joining. Send your name in the chat. We do have a chat feature on the bottom right. Like I said, my name's Maria. I'm coming from Orlando, Florida, so it is hot over here. But yeah, Mark, where are you joining from?
Hey Maria, I am joining from the Nashville, Tennessee area. Not quite as hot here. Actually pretty pleasant.
Nice. Yeah, it sounds nice. Awesome. For those of you joining for the first time, we do have a questions feature as well as a chat feature. So if you have any questions or you have any comments, please feel free to chime in. We would love to see that. And we'll get started here in a moment. Hope everyone enjoyed the short week. I know it's always a little different when you're coming back from a long weekend. Back to normal next week. All right. Cool beans. All right, so we can go ahead and get started here. Like I said before, my name's Maria. I am a marketing coordinator here at UpKeep. We are so excited to put on the sensor technology and food and beverage production webinar today. If you have any questions, there is a questions feature down on the bottom right of your screen. Please feel free to let us know. There's also a chat feature. If you have any comments or concerns, let us know there too. But yeah, I will go ahead and pass things over to my expert, Mark. Take it away.
Thanks, Maria. And hey, everybody, my name is Mark McKelvy. I'm a product manager here at UpKeep, and today I'm excited to talk to you about how you can use sensor technology to level up your maintenance team. We have a jam-packed agenda today. We're going to start by talking a little bit about the evolving requirements of a modern maintenance team. What has stayed the same? What has changed? How it all impacts you, and how leveraging sensor technology can potentially help you and your maintenance team. From there, we're going to go talk about some of the considerations for a sensor solution, what the goals should be for any sort of solution, what that solution might look like. And then we're going to wrap up with some customer examples and some Q&A. So with that, let's go ahead and dive in. I want to start by talking about these evolving requirements of a modern maintenance team. When you think of the requirements for a maintenance team, what comes to mind? What does your maintenance team need to do? Well, chances are it's some version of detect failures and respond, prevent failures in the first place, and then maximize the availability and the utilization of your assets. These all probably look really familiar. It's what your maintenance team does day in and day out. In other words, the what of the maintenance team's requirements, your team's requirements, well, that's probably stayed the same. But what's evolved is how you're supposed to fulfill those requirements. That has changed a little bit in the past few years. Not only are you expected to detect failures and respond, but you need to do so immediately. You need to do so. You need to be everywhere, kind of all at once. It's also not good enough to just prevent failures. You have to do it cost effectively. You have to do it faster, more efficiently, and with fewer people. And finally, you have to maximize availability and utilization for your assets, but the requirement is much more precise now. What was the availability of an asset yesterday, last week, over time? Which assets are underutilized, overutilized? People want data, and they want lots of it. So how do you deal with all of this? How can you possibly satisfy these new demands? Well, sensors can certainly help you out. And let's explore that by walking through each requirement. Let's start with detecting failures and responding. How are you all detecting failures today? Well, one approach you could take is the manual approach. You could have your technicians take periodic meter readings. You can wait for somebody to report an issue. You can wait until you observe an issue. But there are issues with this manual approach. What happens if your facility is remote? If the problem occurs after hours? Or if the problem occurs between regular inspections? What if your response time isn't fast enough, resulting in a critical failure? We've seen this with some of our customers. We've had folks in the restaurant space where they've had a freezer that goes down after closing. It spoils high-value product, creates like a big time loss. We've also seen beverage manufacturers. They've had a line go down and it ends up costing thousands per hour per line. These are big costs. There's something that you have to deal with. So what if you took a little bit of a different approach? What if your assets could tell you if something is wrong? What if you could get an alert? You could get a notification without anybody having to go and take a look at that particular asset. Well, it turns out your assets can with sensors. You can use sensors to track key asset conditions like temperature, pressure, and vibration. Nearly all assets are going to draw current, so you can use that to monitor whether a machine is off or on. And with these sensors in place, you can trigger alarms when readings are detected outside of an expected range. And you can basically have your assets write their own work orders. So what this does, this addresses all of those shortcomings of the manual solution. Now you can monitor conditions at remote locations from anywhere. You can monitor conditions 24/7. You can get in front of issues quickly, and you can reduce your response times. You can prevent incidents from becoming critical. So the question is, if you're going to implement a sensor solution to detect failures and respond, what should you be monitoring? Well, you should be monitoring the conditions that reflect the health of an asset. So for instance, if you have a walk-in cooler, you're in the food and bev space, maybe you want a sensor to monitor the temperature of the cooler. Maybe you want a sensor to monitor the open and closed status of the door. If it's left open, you can create a work order, create an alert, get somebody out there, make sure that you're not going above the necessary temperature ranges. If you have a manufacturing asset, maybe you could have one sensor that's monitoring the current draw of the machine, one sensor monitoring the vibration of the motor, and one sensor monitoring like the temperature of the bearings. You could bring all of this data together and give you a holistic picture of your asset. And most importantly, you'll know if something goes wrong immediately. So that's how you can use sensors to detect failures and respond, that first use case. What about preventing failures? Let's talk a little bit about that. So how do you prevent failures in the first place? Well, you prevent failures by implementing a preventive maintenance program. A solid preventive maintenance program keeps conditions favorable and prevents downtime. It allows you to be proactive instead of reactive. And chances are this is something that's very familiar territory for you all. You all probably have a preventive maintenance program in place. But what I want to talk a little bit about is how you structure your PM program. Should you go with a calendar-based approach or a usage-based approach? Well, there are pros and cons to both. Let's start with the calendar-based approach. So the pros are it's easy to set up, easy to schedule, but the cons are it's inefficient. It results in too much or too little maintenance. You're not matching your maintenance to the actual usage of your machines. It's kind of similar to if you're getting oil changes for your car. You have the option of every 6 months or 3,000 miles, but which one is better? Well, if you do it every 6 months, what if you drive your car all the time? Then you're probably going to hit that 3,000 miles a lot sooner than 6 months. You're under maintaining. Conversely, if you don't drive your car that much, it might take a year to hit those 3,000 miles, in which case you're over maintaining. So it's inefficient. It also ties up resources that can be focused on higher value work. and it also results in additional downtime. In a lot of cases, in order to perform maintenance, you have to bring the machine down. So let's take a look at usage-based maintenance for your preventive maintenance program. What are the pros of usage-based maintenance? Well, it's efficient. Maintenance occurs at just the right time. It reduces costs. It's more efficient. It's less costly. You're only doing the maintenance that you have to do. It also prevents extra downtime. You only have to do maintenance, again, when it's necessary. You're not doing maintenance on calendar-based cadences when the machine doesn't necessarily need that maintenance. So what's the issue here, though? The con is that setting up a usage-based maintenance program, well, that's difficult to set up, and it's difficult to schedule manually. That's the key point there. It's difficult to set up, and it's difficult to schedule manually. But what if we could automate a lot of that manual process? What if you could use sensors to make usage-based maintenance a lot easier? What if you could automatically track runtime? If you could automatically track cycles? If you could automatically track production count? And then you could use these to drive your preventive maintenance based on these metrics. Kick off a work order every 5,000 hours. Kick off a work order every 1,000 items stamped or items produced. These are real ways that you can leverage sensors to make a usage-based maintenance program a reality. Now, what kind of sensor types would you use? Well, you could, in a lot of cases, it's really good to use a current sensor or a voltage sensor or a pulse counter. So current sensors can measure when a machine is on or off, and you can use that to calculate a runtime or running hours. A pulse counter is great if you're trying to do more of kind of like account-based maintenance tracking, in which case you can track how many items you've produced, and then use that every 40,000 items produced, you need to schedule a work order, schedule your PMs. The end result is a step change in your maintenance team's productivity and a reduction in costs. So that's preventive maintenance. We've talked through how we can detect and respond to failures. We've leveled up our preventive maintenance program to prevent failures in the first place. Now let's take a look at how we can go even further to maximize availability and asset utilization. First, let's take a quick step back and ask, well, what is, or why should we be focused on availability? Well, there's this metric called OEE, or overall equipment effectiveness. This measures how effectively your assets can drive your bottom line. And it turns out one of the key components of OEE is right over here, it's availability. And guess what? Maintenance teams drive availability. This is where you, as a maintenance manager, as someone on a maintenance team, this is where you have a direct impact on your company's bottom line. So the question is, how do you do that? How do you maximize availability? Well, a great step towards this is to start minimizing downtime. And you might say, well, I'm already responding to problems immediately. I have my preventive maintenance program dialed in. What more could I do? Well, a great place to start is by tracking and understanding your downtime events. So we're already responding, we're already trying to prevent it. But if it does happen, let's start understanding which asset went down, how long was it down, and why was it down. Once you start doing that, you can start identifying troubled assets and you can take corrective action. And in a lot of cases, we've seen it so many times, people don't know which assets are causing the issues. They don't know that there's an asset that's continually having issues, breakdowns, et cetera, is costing the company a lot of money. This helps shine the light on that. But again, the key question here is like, okay, great, that sounds good, but how do we do it? All this age-old question, how do we do it? Again, the option that we see time and again is the manual approach. We can use work orders as a proxy for downtime. Tech starts a work order, that means that's the start of a downtime event. Tech ends the work order, that's the end of the downtime event. You can also update the asset status. You have the techs make sure that they update the asset status anytime they trigger a downtime event. Or sorry, anytime they're working on a work order. What's the problem with this though? Well, it's usually a very inaccurate summary of downtime. It's really hard to remember to set the asset status. Work orders are kind of a poor proxy. You don't know when they actually started the work order. What did it actually correspond to the downtime event? When they ended it, did it also correspond to the downtime event? You don't know. A lot of downtime events might be on the shorter side. They might only take 2 to 3 minutes or something like that. In which case you're missing a lot of downtime by only using work orders as a proxy for downtime. So what we've found is that the only way to really get an accurate read on downtime is to let the asset tell us when it's down and why. And this is where sensors come into play again. Your sensors can record downtime events. You put a current sensor on the power source of your particular critical asset. That sensor will detect when the asset is running or not. Now you have a true source of truth for your downtime events, and you can start to understand what is happening across your entire asset portfolio. And I've added this other bullet, what about the why? So it's great to track the downtime events, but isn't it good to start understanding why things went down? I mentioned that a little bit earlier. How does just tracking the downtime events, how's that going to get me to the why? How are sensors going to help me here? Well, remember we talked about putting a current sensor on your critical asset, but we also talked about adding other sensors, vibration, temperature. So what you could do is you could check the conditions that were present before the downtime event occurred. So you can start to understand, you can start to paint a picture. Hey, temperature dropped, temperature rose, vibration went through the roof right before we had a downtime event. I don't know, there might be some issue with the motor. Maybe the bearings need to be replaced. You could start to get a great understanding of why these downtime events are occurring. And that's a critical step to start to address these issues, for the long term. So again, the benefits here, more accurate, more scalable. There's really no way to accurately track downtime unless you're using some sort of automated solution. It allows you to identify assets that need more attention. It gives you better insights as to the why, and most importantly, it gives you the insight you need to reduce downtime. The other great thing about using a sensor solution is that sensors are great not just for tracking downtime, helping you level up that availability. It also gives you a sense of which assets are underutilized, which assets are overutilized, and you can adjust accordingly. It gives you the power to identify trends and surface insights across your assets and get the data your C-suite wants. So those are some of the benefits, some of the use cases for a sensor solution. Now let's talk a little bit about some of the sensor solution considerations. The place to start is with the goal of a sensor solution. There are a lot of solutions out there, a lot of IoT projects, a lot of buzzwords. You don't want all of that. You want a sensor solution tailored to maintenance teams. And this slide is very simple. Purposefully so. Your solution should do 3 simple things. Number 1, collect machine data. The data points we talked about: temperature, current, vibration, humidity. Important pieces of data relevant to your needs, relevant to your asset conditions. Number 2, you need to make sense of that data. The data needs to be converted from signals and ones and zeros to things that matter to you: conditions, run hours, availability, production counts. And finally, that data, you need to get that data where it needs to go. You need that data to drive work orders, dispatch teams, generate notifications, build utilization and downtime reports. It's not enough just to have a fancy dashboard, which is what a lot of sensor solutions end up being. You want it to drive action and surface insights that matter to your team. So keep these goals in mind. It's very simple. Collect the machine data, make sense of it, get it where it needs to go. Question is, okay, well, what does that actually look like? What are the components of a sensor solution? Well, a sensor solution, it starts on the plant floor. It starts on the plant floor, interestingly enough, with sensors. So these sensors can be either sensors that are already on your machines, on your assets, attached to control systems like PLCs, or they could be add-on sensors that you buy separately. From there, the sensors are going to probably need some sort of gateway or edge device. Gateway or edge device is typically responsible for collecting readings from all the various sensors, doing some initial processing and aggregation, and then sending those readings to the cloud. Once the readings get to the cloud, they are processed, further stored, and then used to drive applications. This is where the rubber meets the road. It shows up in places like UpKeep, where your team can create alerts, drive work orders, level up their preventive maintenance program, and understand availability and utilization. So there are a lot of ways to build this system, to build these components, but there are really two main options that you have to consider. Number one, you can integrate with an existing system. This is like integrating with the sensors that are already on your asset. Maybe it's like key end sensors, banner sensors. It's sensors that are controlled by maybe a PLC or a programmable logic controller or control system. And the pros of this approach is that it leverages your existing infrastructure. It gives you higher frequency, higher fidelity data. You have more data points available, and it's customizable. There's a lot of pros, but major con: difficult to set up, very difficult to get this set up. Requires assets to be on a network in most cases, and it requires multiple teams and specialists, people running network drops, understanding which tags correspond to which metric within your PLC. It's a big undertaking. Conversely, if you use an add-on sensor solution, it's easy to set up. You just have to take some sensors, put them on your asset of choice, connect, in many cases, connect to gateway. A lot of times it'll transmit data over a cellular network, and you're good to go. It doesn't interfere with existing programs or operations. You don't have to get into the guts of the PLC, mess with any of your programs, and it can be added or removed as needed. Try it out. See if it works. If it works, great. Add more, keep it the same, or if it's just not something that your team needs, you can remove it, and there's no big cost, no big process. There are some cons to the add-on solution. You're going to probably have more limited data points, right? So you're going to be limited to the data points that the sensor provides. So if it's a temperature sensor, it's going to give you temperature, and that's it. If you got a current sensor, it's going to give you current. Maybe it gives you average current. Maybe it gives you max, something like that. But the data points are fixed. You don't have the entire menu that might be available in a PLC, for instance. It's not as customizable. Again, it's not your system, it's somebody else's. And then in some cases, the data might be a little bit lower frequency, lower fidelity data. In many cases, that's okay for a maintenance applications, but it is something to consider. So what's the right solution for you? Well, it all depends, of course. But what I would say is, if you're implementing a solution from scratch, start with the add-on solution. See if it meets your needs. If it does, great, you're done. If not, then you can look at building out an integration with your existing systems. If you already have something in place, if you already have a SCADA system like Ignition, if you already have some existing sensors, maybe you've already set up IO Link or something along those lines, then go ahead and leverage your existing infrastructure and just connect it to the cloud, connect it to the tools that you use, like your CMMS, and you're off to the races. So again, it just depends on your individual situation. You're just getting started though, probably start with an add-on sensor solution. So that's an overview of kind of your solution considerations. I want to wrap up with just a couple customer examples here. I want to start with one of our customers, Primal Pet Foods. As you might expect, they're a pet food manufacturer, and they came to UpKeep. They were very reactive in their maintenance practices. They had inefficient work order management, lack of real-time visibility into their maintenance operations, and most importantly, they had a high cost to downtime. So one production line going down, that costs up to $160K per day. This is a tailor-made use case for leveraging sensors. If downtime is that costly, get a sensor on that particular asset so that you know the minute it goes down, and you can take corrective action accordingly, and you can save $160K. That is a great way to get noticed, to highlight your maintenance team, and to just level up your organization. So that's exactly what Primal Pet did. They adopted UpKeep, and they used a key component of UpKeep, which is our UpKeep Edge sensor solution. And the great news is that This helped them transition from a reactive to a proactive maintenance approach. And they've had a number of occasions where one of their assets, it does go down. There's an issue either with something on the line or one of their cold chain assets. They get an alert from their sensor solution right away. They're able to address the issue. Very simple, very simple. Get an alert when something happens, but the value is absolutely huge. So that's Primal Pet. We have one other customer example I want to just talk through briefly, and that is Icon Entertainment. Icon Entertainment, they are an entertainment company, also manage a bunch of restaurants. Similar story, unreliable equipment, reactive maintenance practices, lack of asset visibility. In a similar situation, an asset going down has a really high cost. Losing a refrigerator results in $10K in lost product per incident. So that's something to consider. So what did? They implemented UpKeep, including our UpKeep Edge and sensor solution, and they started seeing benefits immediately. Now they know exactly what's happening across their cold storage portfolio, and the sensor solution paid off very, very quickly. They had an issue where one of the refrigerators went down after closing. Boom, sensor detects it, sends an alert to the maintenance team. They're able to come back on site, move the product to a refrigerator that works, address the refrigerator that had gone down, and prevent tens of thousands of dollars in loss of product. So again, this is a situation where they've leveled up everything simply by using an add-on sensor solution, which we provided for them. So that is kind of an overview of some of the use cases, some of the considerations as you're trying to build a sensor solution, and talking through a couple of the customer examples of what that looks like. I want to stop talking now for a minute and go to some Q&A. I'm going to pass it back over to Maria for that.
Awesome. Thanks so much, Mark. Yeah, so we have a couple questions here. So everyone saw that there is UpKeep Edge, but they want to know if there is a range of sensors that UpKeep offers.
Yes. Right now we offer temperature sensors, we offer humidity sensors, we offer vibration and current. So this is like an initial, I guess, kind of a portfolio of sensors that we offer, and it's meant to cover some of your core maintenance use cases and some of the cases that we've identified, particularly for the food and bev space. Temperature for monitoring like the cold chain, is your freezer, your refrigerator, etc. Is it actually holding the right temperature? And then current sensors to track runtime, run hours, and things of that nature. That said, we're always looking at adding new sensors. So if you have sensor suggestions or you have use cases you think we should really consider, definitely let us know.
Awesome. Okay, we have another question here. I have looked into OEE systems for my site. Because of the complexity and the integration of multiple machines, I'm finding it really difficult to log and track what's causing the downtime. Ideally, I want to log when machine doors are opened, for example. Do any of the UpKeep sensors and off-the-shelf options allow for this?
Yeah, I think like if you're trying to track downtime, my recommendation for an off-the-shelf sensor is going to be a current sensor. So our sensors, they look like really simple. They look like this. And what we could do is we can take a current sensor, attach it to the power supply of that particular machine, and then we'll know if that machine's running or not. We'll know if it's up or down by leveraging that current. If that's not going to work, there is potentially an open and closed sensor option. It's not available today, but we are looking at that. That might be another way to go.
Awesome. And another question here is, if I have my own sensors, how would I go about using them?
Yeah, that's a great question. So if you have your own sensors, there are a number of ways that you could go about doing this. I think if it depends kind of like on how they're configured. If you're attached to something like a PLC, a programmable logic controller, what you can do is you can actually connect to that PLC if it's a more modern one, and you can actually pull the sensor data out of that kind of like central unit, that PLC. Once you do that, then you can take that sensor data, transmit it to a gateway or an edge device, and then onto the cloud. It gets a little bit more complicated because this PLC is, it's a complicated piece of equipment, or it's a complicated device. But that's generally the way to go. It's like to go through the PLC. If you don't have a PLC, then look at sensors that have IO link compatibility. That means they can be put on a network. That's one of the critical things. Make sure that your sensors or your PLCs can be put on a network. Once you can do that, it gets a lot easier to get that data up to the cloud and into a place where you can use it.
Awesome. And last question here. I am looking into getting started with sensors. What should I look for in a sensor solution?
Well, I think I would point you back to what I mentioned before. Make sure that the sensor solution is going to address your goals. Like, you're going to collect the data that you need. It's going to put that data in a format that makes sense for you. If you're trying to drive your preventive maintenance program based on run hours, make sure that your sensors are going to be able to convert that data, or your solution, I should say, is going to convert that data into run hours for you. So, and then finally, make sure that that data is going to go where you want it to go. So instead of just, there are a lot of solutions that end up with just a fancy dashboard, but it doesn't end up getting used because it's not connected to your CMMS, for example. So make sure when you're building a sensor solution, they can connect to the tools you need and start to drive action, create work orders, trigger alerts, drive your preventive maintenance program. Those are some of the things to consider when you're starting with a solution, or looking for something in a solution, I should say. I want to add one more thing: ease of use. If your sensor solution is extremely difficult to set up, you're not going to do it. So find something that you and your team can get set up.
Definitely. That is some awesome advice, Mark. And for anyone who is following along with the customer stories and, everything, we added some resources here in the chat. You can check out more on Primal Pet Food Story as well as Icon Entertainment. And if you're interested in looking more into UpKeep sensors, there is a page linked there as well. So awesome. Thank you so much for everyone for joining. We'll see you next time. Thanks, y'all.
Awesome. Thanks, everybody.